Hello everyone, today we'll talk about the solution to the problem fraction, addition and subtraction. This is one of those problems where if you explain it to somebody who's not a programmer, you say, well, this is a string, that string is just a sequence of adding and subtracting fractions, irreducible fractions, and you want the result to be an irreducible fraction. Well, it sounds very simple, and of course the devil's in the details, and this problem becomes pretty annoying. Now there are two parts to this problem. The first part is to actually get at what the fractions are in order to calculate the result, so parsing the original string. And the second problem is how to perform the operations on the fractions. So the second part is just basic math, so let's start with it. In general, when you have a divided by b and you want to add it to c divided by d, the easiest way to do it is, and you want of course to have the result be an irreducible fraction. So in general, when you have an irreducible fraction, so this is kp by kq, p and q are prime. Of course, this is the same thing as just p over q. We can divide both the numerator and denominator by this value k. So in other words, this k can be equal to the greatest common divisor of this kp, kq, right? So to reduce a fraction, to get an irreducible fraction, we just find the GCD of the numerator denominator, divide both by that number, and it's irreducible. So in this case, we have to reduce the result, and that result will be a times d over b times d plus c times b over d times b. So we just multiply everything here, both above and below, by d, everything here, both above and below, by b, then the denominators are the same. So b times d, d times b. So this is the same thing as if we put the plus here, and d times b is here. So that's the basic idea, right? You multiply it across and reduce it using the GCD. And now the problem is parsing. You can use some tricks using regular expressions, using regexes, but I tend to think that regexes are not only pretty difficult, but they are also right-only. So you can write a regular expression, a regex if you like, but if somebody else comes across it, then the probability that that of course what you've written is correct, that he understands exactly what you wanted, and he doesn't spend eternity doing so is very low in my opinion. So I tend to avoid regexes if at all possible. But in that case, the only alternative, or the only real alternative, is just to parse those things by hand. Luckily, in this case, it's not that difficult, because we are, for instance, we do not have to worry about something like we have some fractions here, then we have to subtract minus like 2 over 3. So there are no two minuses next to each other. So the structure is, at the beginning maybe there is a plus or minus, and then we have a numerator over denominator, and again plus or minus, and so on. So you can just split the string using pluses or minuses. We'll still use the regular expression module, but that's just because the string split function, it does not allow us to split on either one or the other, so either plus or minus. And it's explicitly said in the docs to just use the RE split. So we split over pluses and minuses, discard empty strings. So one way is just to filter by bool, because bool will just tell us if the string is non-empty. That's useful because maybe the first string that we get would be empty if the original string starts with a minus. Then we would imagine that the first element, the first fraction, is just an empty string. We convert it to the list. Likewise, and of course, since we would preferably have list of pairs of integers, we can just do that. So take every fraction that we have, split it over the slash, which separates numerator and denominator, convert them using map to an integer, so we get as a list those two element lists representing every fraction, for f in those raw fractions that we split the original string into. Operations, again, we go through everything in our expression, and now we keep only the things that are a plus or minus. And now to make sure that we have the same number of operations and pairs, we can because maybe we can have one fewer operation, if we do not have a minus at the beginning of our expression, so we can imagine that our expression starts with a plus. So it's nothing plus the first minus the second and so on. Or nothing minus the first plus the second, whatever. So now operations and pairs have the same length. And then in order to add everything, so to take this idea, this reducing, taking the multiplication, to multiple fractions, we can first have their common denominator. And that common denominator is just the lowest common multiple of all the denominators, so all the elements at index 1. And to get the lowest common multiple, we can just multiply and then divide by the greatest common divisor. So that's also basic maths. And then to make sure that our fractions are correct, we also have to multiply the numerator. So for every fraction, we multiply the numerator by the common denominator divided by the original denominator. So if the common denominator is 6, the original denominator of the given fraction was 2, then we have to multiply 2 by 3 to get 6. So whatever was above, for instance 1, we multiply 1 by 3 to get 3. And now we start with the numerator being 0, and we just either add or subtract the following numerators, because now everything has the common denominator. And we have to add the next numerator if the operation is plus, otherwise we have to subtract it. So one way of doing that is just multiplying the numerator by 1 minus 2 times the operation being subtraction. So if the operation is not subtraction, we multiply it by 1 minus 0 by 1. If the operation is subtraction, this thing here is 1, this thing here is 2 times 1 equals 1, 1 minus 2 is minus 2, so we multiply the whole thing by minus 1. And at the end, of course, we also have to reduce the fraction, because our current fraction is the result of all those addition and subtractions by the common denominator, so we get the GCD of that and common denominator, and we write, separated by a slash, so we use a format string, the numerator divided by the common denominator over denominator divided by the common denominator. Well, a pretty annoying problem, but luckily the code, at least doing it this way, is not too difficult and I think pretty readable.